Welcome back, dear students, to this other video on memory management. In the previous video, we introduced contiguous memory allocation and we talked about the different allocation algorithms, that is, different algorithms used by the memory manager in order to place different processes according to the partitions available in the main memory. And in this example, as we said while concluding with the previous video, in this video we are going to have an example to better understand how these different algorithms work. Let's consider memory partitions of 120K, 450K, 180K, and 300K in that order, and four processes P1, P2, P3, and P4 of 200K, 380K, 140K, 285K respectively. For each of the algorithms below, use a diagram to show how the processes are allocated to memory partitions. That is the first fit, the best fit, the worst fit, and the next fit. Then the second part of the question says, calculate the total fragmentation for each of the algorithms and hence determine which of them makes the most efficient use of memory. Okay, we are going to start with the first fit algorithm. As you can see, we have the different partitions. We have 120K, 450K, 180K, and 300K. And the first fit algorithm, as we described in the last video, allocate each process to the first partition, to the first unallocated partition that is big enough to accommodate it. And our first process is 200K, and we see that 120 cannot, but 450 can. So the 200K will be allocated to the 450K. So we are done with the 200K. Now, when we take the 380K, we start from the beginning. This cannot, this is already occupied. We come here, this cannot, and this cannot. So among the unallocated memory left, there is no partition that can accommodate the 380K process. So this one will not be allocated. Then the 140K, when we come here, this is not enough. When we come here, this one is enough. So the 140K goes to the third partition. So we are done with the 140K. Then for the 285K, this cannot, this can, because we are always starting from the beginning. So the 285K will be allocated to the fourth partition. So for the first fit algorithm, we have P1, P3, and P4 which are being allocated to partitions, and we have a single partition which is not allocated. Now, we move to the second one, the best fit algorithm. And the best fit algorithm does what? When we have a particular process, it identifies the unallocated partitions and select the smallest of them. And from there, we attribute the process to that particular partition. So we have the first process, which is 200K. And we see that among the different partitions, it is this one and this one which can accommodate the 200K. And among this and this is the smallest one. So this is where the 200K process will be allocated. And it is true, it would have been better if I put the process P1, P2, but in order not to bring in confusion, that's why I prefer to put the different size for you to understand better. In the exam, it will be good that you put the process, then under you put the size, or you just put this, you simply put the process, it will be better. Now, 200K is okay. Now, 380K, among the free ones, this is the only partition that can accommodate the 380K. So this one is going to be accommodated. Now, the 140K, the amount for the different partitions left, only this one can accommodate 140K. So this one is going to be allocated. So we are done with 140K. Then for the 285K, the partition left cannot accommodate it. So 285K won't be allocated, and that first partition remains free. Good. We move now to the worst fit algorithm. And the worst fit algorithm does that what? Among the partitions that are left, it choose the largest of all. So the 200K, the ones that are possible to accommodate 200K, we have this, and the largest is 450K. So this is where the 200K will be. We are done with 200K. 380K, there is no partition that can accommodate it, so it remains unallocated. The 140K can be allocated to this partition or this partition, and the largest is this one. So the 140K will be allocated to the fourth partition. So we are done with that one. 285K, among the partitions left, which are free, none of them can be allocated with the 285K. So this will not be allocated, and we have two different partitions not allocated. That is how the worst fit algorithm will work for this particular schema. Now, the last one, the next fit algorithm. The next fit algorithm works like the first fit, just that when we have a particular process, we continue from the last allocated set. So now, the 200k among 1, 2, 3, 4, these two are possible. Sorry, it works like the first fit. So we come here, it is not possible. When we come here, it is possible. So the 200k will be allocated here. 380k, we start from here, not possible, we come here, not possible, we come back, not possible. So there is no partition that can take the 380k. Then we have the 140k. We start from where we ended, so we are starting at this level. Can 180k accommodate? Yes. So 140k enters here and it is okay. Then for the 285k, we start here. Can 300 accommodate? Yes. So it enters here. And we are done with the 285k, and we have the same schema like the first fit algorithm. That's why we said the next fit algorithm is a small optimization of the first fit. So for most of the cases, you will have your next fit algorithm working exactly like the first fit algorithm. So now let us look at the the second part, which asks us to calculate the total fragmentation for each of the algorithms. So now at this level, total fragmentation is the sum of internal and external fragmentation. And in the previous video, we show how we can obtain these different fragmentation types. So this is what we have in general. I'm going to explain for the first fit, and you are going to see that it's the same thing for the other fit. So for the first fit, this is what I have. I just took back this table and I reproduce, as you can see. Then the unused size is another column that will be added, and the difference between partition and process. So this minus this, I have 250, 180 minus 140, 40, 300 minus 285, 15. That is what we have. Best fit, you reproduce the table. Take note that for a particular partition which is not allocated, the unused size remains empty because we are going to reference to it in order to calculate the external fragmentation. Because you need to know that the internal fragmentation is the sum of the unused portion from partitions that have been allocated, while external fragmentation is the sum of those partitions which were not allocated. That is why the table is, as you can see, same thing for worst fit and next fit. So now for the first fit, internal fragmentation is 250 plus 40 plus 15, which is 205k. Then for the external fragmentation, it is simply the partition that was not allocated, which is 120k. Hence, total fragmentation is this 305 plus 120, giving us 425k. For the best fit algorithm, we have as internal fragmentation 70 plus 40 plus 100, giving us 210k. And the external fragmentation 120k, giving a total fragmentation of 330k. For the worst fit algorithm, it has the name because it is the worst. Internal fragmentation, we have 250 plus 160, giving us 410. The external fragmentation, we have two partitions not allocated, 120 and 180, giving us 300, making a total fragmentation of 710k. For the first fit algorithm, so it's supposed to be the next fit. It's just a copy and paste because you see that they're having the same procedure. So why doing the copy and paste? That is not edit. So this is supposed to be the next fit algorithm, and we have the same value for total fragmentation as that in the first fit algorithm because their diagrams are similar. So we are done with the second part of the question. The third part is now asking us to determine which of them makes the most efficient use of memory. And you need to know that from the different allocation algorithms, the one that makes the most efficient use of memory is the one having the lowest total fragmentation. And in this case, it is the best fit algorithm. So the best fit algorithm makes the most efficient use of memory since it has the lowest fragmentation. So I hope through this example, you can already produce such diagrams depending on the algorithm that will be given to you. And do not forget to like, to subscribe, and to share. You thinking that it's the end of the video, it is the case, but we are concluding the video with this sumptuous exercise. So the exercise says, given the memory partition, we have 100k, 500k, 200k, 300k, and 300k in that order. Show how the algorithms below will place the processes of 285k, 413k, 164k, and 512k. So you see that this one is different from the first one because in this case, I have 5 partitions, but I have only 4 different processes. And you are supposed to draw for the first fit, the best fit, and the worst fit. And for each of the algorithm, Determine the percentage of fragmentation over the total memory and hence determine which of the algorithm below makes the most efficient use of memory. And they help you by saying percentage of fragmentation is total fragmentation over total memory times 100% over 1. The hint I'm going to give to students is that total memory is different, is the sum of the memory partitions and not the sum of the size of the different processes. So I am waiting for your comments. You can just comment about the algorithm that makes the most efficient use of memory and you just give its percentage of fragmentation in the comment section. Thank you and see you in the next video where we shall introduce the non-contiguous memory allocation.